So this is the slide that I'll be using. And the first one, 6-1, Introduction to Ontology and OWL. Okay. So the outline of this lecture of this slide is that first it will discuss about this is okay. What is ontology, and then the language or the representation that we can use to represent ontology, and then we will be doing some practice session using pizza ontology as an example. Okay, so a little bit, what does it mean by ontology? Ontology is the term that refers to a shared understanding of a domain. So we kind of design or model ontology in order to make a shared understanding of a certain domain. And it means that how it is related to our semantic web technologies or semantic technologies describing the thing, because with ontology, we can provide machine readable and machine understandable content. So the focus is to make this shared understanding of a domain in a way that can be used for machine to process the content. Okay. And let's look at a few definitions of ontology defined by several researchers. Okay, so ontology is not new term. It has been defined. If I refer to this, for example, from 99, 93, 91, and so on. Okay, so what does it mean when we say that share understanding of a domain? Okay, so it means that, okay, this one is easy to understand. It defines basic terms that people will use to refer to things in a particular domain. Basic relations. Okay, so basically what we use in our class, right? Vocabulary. We are defining terms, relations, or in other words, vocabulary of a certain topic area. This is the same thing as what we mean by a domain, right? A domain is an area of the things you are interested in, as well as rules. Okay, rules could mean condition, relation, restriction, axiom. Okay, so this is one definition. Another, okay, not very clear, but kind of short one, but it doesn't tell. If you don't understand ontology that well, you may not understand this so much. Explicit. Okay, this is good. It's explicit. Specification of a conceptualization. Actually, everything we are doing here is to make a conceptualization of things in a topic area, right? Conceptualization about terms, relations, axioms, rules. Yeah. Okay. Then another definition, for example, it gives more detail of how ontology is like as well, such as it is a hierarchical structure, a set of terms. So it's a term that could be hierarchically structured. And actually the usage of ontology is for construction of a knowledge base for a topic area, right? For a particular domain, particular application. And what else? Okay, let's move further for another description. Ontology provides the means for describing explicitly the conceptualization behind the knowledge representation in a knowledge base. Okay, this doesn't add more. Okay, but anyway, so I would like to refer to this short definition, but expand further. Okay, ontology is a formal. When something is formal, it means that it has been defined in a proper way such that certain meanings are defined as well, and in a form that machine can process easily. No ambiguity, very precise. Okay, that's formal. It's explicit, and it is an explicit specification, means that you need to make known the terms, right? Remember, we say terms and relations, and actually to clarify further, it means concepts, properties of concepts, certain relations, even functions, constraints, axioms. These are things that can be defined within ontology. And when it is a shared conceptualization, it means it is widely accepted. It's consensual knowledge. It's not only you that agree. It's agree upon the community of things, domain, okay? And when it is conceptualization, what does it mean? It means an abstract model. It's an abstract model, a conceptualization or a view of something you want to represent in the world, such as could be an ontology of computer science, could be ontology of as we see in examples this morning. What are they? What did you present? In health tourism, yes. Nutrition, exercise duty, right? Yeah, the classification of exercise duty. These are the domain, the conceptualization of things inside this domain, including the classes. Concepts means also could mean class. So actually, what we learn in RDF schema, they are also a kind of simple RDF schema itself allow us to define a simple ontology, because we can define terms, relations, properties, concepts, classes, right? You can even have the hierarchical structure of superclass, subclass, 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 and so on, right? This is actually, we already learned, but we will learn more, okay? And ontology itself, it is a formal approach for knowledge representation. So actually it's one way. It's not like when you say about knowledge representation, it must be ontology. No, ontology is just one mechanism, one possible way of representing knowledge in computer. And okay, ontology is engineering artifact consisting of vocabulary. This is what we already discussed, right? Vocabulary for describing a certain domain, okay? And it has semantics. when you are defining vocabularies, you need to define the semantics, right? The meaning of those vocabularies, and the way to define the meanings are actually through what we have learned so far, but we learn more. That is through organize the concepts in terms of hierarchy. Does it help you to define the meaning? Yes, because this is more specialized, this is more generalized, this is also the meaning, right? This concept or class has properties, these are also meaning. This concept has relations with other concepts, this is also the meaning. You define the meaning of how things are related to. Okay. This is the same thing, okay, just different ways to define. How can we use ontology? Actually, it's kind of knowledge based, right? It's a knowledge representation language. So you can use it for knowledge based and database applications. This can be kind of foundation for knowledge layer, database layer. It can be used in certain applications such as building certain software agents, domain application, domain independent applications, problem solving mechanism, and so on. I think in several of the papers you presented and you listened today, there are kind of examples, right, that we use ontology to serve as knowledge construct for answering and recommending certain things to the users, right? Okay, so some components, okay. When we talk about ontology, there are 4 main components that we can define or model. First, concept, class, category, type. These are kind of synonyms or similar, have similar meanings. Okay. So actually, we want to represent concepts in a broad sense, such as animal, university, person, and so on. Remember your own refer back, think back, your RDF schema that you model. You define classes, many classes, right? You define subclasses. These are first components. And don't forget as well that don't mix, okay? Those modeling principles we learn still apply. What does it mean by instance? Don't mix it with the class, okay? We are an instance of the class person. For example, you are an instance of a class student, okay? So there is no class Shutiporn. Shutiporn is cannot be a class because I'm not a blueprint. I cannot have Shutiporn instance so many things, right? I'm an instance, okay? All right, that is the first component. Second, yes, once you have class, you can have instance or individuals or objects, okay? These are synonyms. And next component, actually you already defined, right? In IDF schema, class may have properties or relationships with other classes. Sometimes in other theory, they may use the term slot, the same thing, okay? Or attribute. They may mean the same thing. Another one, the last component. This is what I already mentioned. Rule or axiom or constraint. They are used to define some kind of conditions that you may want to impose, restrict. We will see some examples. I skipped something first. Okay. Okay. When we talk about elephants, Okay, I want to define an ontology about elephants, related to elephants. Is my first question. 1, 2, 3, 4. Is elephant a class, instance, relation, or constraint? What is an elephant? Okay, I heard 2 answers, and that is always the case because it could lead to some confusion. I'm not talking about particular instance. I'm not talking about particular, elephant. I'm talking about elephant. When I talk about elephant, do you have any conceptualization pop up in your mind here? Maybe draw it here. Okay, draw it. Okay. Yes, but itself, what is it? It can be a concept. It can be a class, right? Okay. But if it is an instance, then we are talking about an individual elephant. Maybe you have one at home. Suppose it is a pet, okay? Raise one at home, that is an instance. But if we talk about general concept of elephant, that look like this, having big ears, having this, having long nose, and very big animal, mammal, right? This is a class, okay? So it can be a class or we can call it a concept. You can think of a concept elephant. You are not referring to a specific elephant in this world, right? Then that can be modeled as a class. And it can be a subclass of animal. How about adult elephant? Is it a class or is it an instance? Also a class, yes. Okay. It is also a class, but then a subclass of elephant, right? Elephant is more general. Adult elephant is some specific type or subtype of elephant. Okay, good. But then adult elephant alone, maybe when I tell you an adult person, what do you mean? What do we mean? In general, the concept of an adult. Pardon? Oh, okay. Are you an adult? Again, age is greater than some value. What is that value for adults? Definition? Internationally, do you know? 18? Yeah, human. 18 in your country, above 18, you consider 18 and above consider an adult, that you can do anything. Because if you are not an adult, you are a child, right? Not adult then means child. You cannot do something, right? An adult can do this, and that without asking permission from parents by law, right? That is definition of adult in general. Why do we need to define? Because of course, by law, there are some things children alone cannot do. So in your country, what is the age? 18? 18, you can do almost everything. Okay, marry, getting married. Without getting permission from parents. Huh? Mm-hmm. What is the restriction? That means you have to be older than 21, then you can. How about 20? No. Oh, crossing 20 doesn't allow. Even going to a pub or something, a disco pub, something like that, we must be above 21. Mm-hmm. Okay. All right, good. Back home, Thailand, what is the age for adults? 18 or 20? You're not sure, or you want to give two answers? Okay. So can you get married now? Above 20 already? Okay. Yes, I mean, that is in Thailand, yes. But as I said, internationally, I'm not sure, but different countries may have different rules or laws. But for example, adult, we consider a person to be adult in Thailand when they are 20 or above. Then they don't need permission from anyone. But if they are below and there are certain things, they still consider a child somehow, that if suppose like getting married and doing something, they still need permission from parents. Or if they do something wrong, commit a crime, going to jail, for example, there is jail for youth and young people, and jail for kind of prisons for common anyone, right? So below 20, you can still go to the we should not call it jail, right? It should be called a kind of special home or something. Yeah, something like that, in which the case, I mean, if someone commits a crime and he is an adult, I think the sentence and the things will be considered that the person has already has been mature, right? Mature enough so that we cannot have an excuse that, oh, they are still very young, they may not have a maturity, something like that. Okay, then it is very important to define, right? What is the age definition for being an adult? Okay. Anyway, so adult elephant is also a subclass of elephant in which we may need to give some definition. And this is an example of a rule or somehow to defining class or subclass. That is, an adult elephant is an elephant, of course, is a concept whose members must be elephant and age must be 20 years or over. In my example, okay, I'm not sure, I'm not an expert in elephants, but let's assume, okay. And another thing, we will not consider it as adult elephant if it's too skinny, too small. So I have two definitions here, such as 20 years over and weight at least 2,000 kilograms. Okay, then these qualify a given elephant to be adult elephant. Okay, and we can further classify elephants into African elephants and then Indian elephants. So again, these two are classes or instances. Classes, right? Because we are not talking about a particular instance. We are talking about African elephants as a whole, Indian elephants as a whole, in which, do you know how are they different? Not only geographically. So if I show you photos of elephant, can you tell me this is African or Indian? Not sure. Aha, interesting. The one from online, do you know how African and Indian elephants are different? Size? So which one is bigger? Ears? African elephant has bigger ears. Yes, very big. How about brains? Brain size. Which one are smarter? The smarter must have bigger brain size, right? So African is what? Lakash, what are you explaining? African has bigger brain or what? I mean African elephant. I think Indian elephants are smarter. Okay, from what I recall, they have bigger brains and smarter. Okay, I could be wrong, sorry, but I think I learned from documentary. Anyway, so these are examples of classes, subclasses, concept, hierarchy that we can define. So what does it mean? It means here that, okay. I need it means actually we do have, of course, oops. Above, maybe we may have animal, we may have mammal, we may have many more, okay? But then we do have elephant. Under elephant, of course, there are a way to define as adult elephant. And adult elephant, okay, I just take some notes, okay, is defined to have age greater than 20, yes, thank you, plus weight greater than 2,000, okay, kilogram. And actually, there's also African elephant, okay, plus Indian elephant. All of them here are classes. Okay, we are defining classes hierarchy. So these are in terms of number one components, right? But here, actually, I think for number 3, you can see that it means somehow for elephants, we somehow want to define age and weight, property, right? But maybe not only for elephants, any animal we may define from the property from the superclass, right? That animal, every animal has age and weight. Maybe you can even define it to have some name and many more, right? And then remember, properties from superclass can inherit to subclasses, right? So something that are defined for the superclass, we have inheritance concepts here. So these are class. Oh, this is number 1, class. And then Then number 3 are kind of properties. Actually, these are example of number 4, right? You can define some axioms or rules that if for adult elephant, age must be like this, weight must be like this. And then for number 2, instance. Meaning that, okay, let's try. Okay, I can draw. Okay, oh, today I'm doing good. Okay, this is in my zoo. I do have this elephant. Maybe I call this elephant Mali. Okay, sorry. Okay, and Mali, this is the name. It has age. It is an elephant. It has age 21. It has weight 2,200. Okay, let's say this. So these properties and the values of Mali. This is an elephant. I can only say that it is an elephant instance with the properties, values, and so on. But then, if I ask you, is Mali an adult elephant? Can you answer me? Yes, it is, right? If I change the value of Mali, okay, she is now 15 years old only, but she overweight. Sorry, she eats a lot. Is she an adult elephant? No, she doesn't qualify the conditions, right? Okay, so this ontology, this is an example. Ontology can do some kind of, what is this? What is this thing I asked you? Sorry. This is called reasoning. This is a reasoning that computer can do. So what does it mean by reasoning? It means that you derive new knowledge, even it is not known. But there might be some rules, some conditions, some concepts defined, and something that is known, but you derive something additionally that is not known or not given explicitly. That is called reasoning as well. So reasoning means also oops, not this one. Actually, this is ontology, right? I did not write in some order. But given all these 4 components of classes or concepts, properties, instances, and then rules. This is what we define in an ontology. And actually, we say that it is a kind of modeling and knowledge base. And ontology is a kind of knowledge representation here. Okay, to model a knowledge base, to model a particular domain, conceptualization, and so on. So these things are model. Remember, we say that we define them as explicit knowledge, but still you can derive or yield something that is implicit. When you can do that, we call that we can perform some kind of reasoning. Okay, let me give another example. We already saw one example of the Mali, whether she is an adult elephant or not, right? Let me give another example. This is John. Okay. This is Mary. Okay. If I say Mary is a wife of John, I only say this. Okay. What implicit knowledge you can infer? Pardon? They are married. Yes. Okay. I tell you only one thing, right? You telling me something else that I have not explicitly defined. Anything else? Yes. So John is a husband of Mary. Yes. Yes. But how do we know that? Is it known by everyone? This thing? We know this because actually there is some rule saying that if A is wife of B, I can tell that B is husband of A. A can be anyone, B can be anyone, as long as they are human person. Okay. Maybe we are not talking about animals, right? Or maybe we can, okay? If this same knowledge applies. But anyway, so this is because this is what? Rule. You know this rule. If you don't have this rule, if I ask a little kid of 5 years old, maybe that kid doesn't know this rule. That kid cannot derive this knowledge, right? But you know, the same. If we give this knowledge known by a computer, computer can and we tell computer only this fact, then you know I am always confused. Sometimes it happens here, sometimes it moves there. This kind of bar. Okay, this yellow is explicit things. Blue is kind of derived knowledge based on this rule. If we define this rule, okay, together with this knowledge, these facts, we know facts. or data, then these blue things can be derived, right? They must come together. And this applies to any other example as well. If you can define some rules, some class, some concepts, some properties, plus certain knowledge and some rules, you will be able to perform a reasoning to derive something that may be not explicitly defined. Okay, and that is why we need to do, that is what we learn in knowledge representation. We represent knowledge, but you don't want to represent everything explicitly, right? Sometimes you want to kind of compactly represent something as knowledge rules. Then you can only store data only smaller, okay, and store it in the knowledge base. So in my knowledge base, I can store only the yellow parts and leave alone all the blue part to be reasoning, to be part of the reasoning results. Okay. All right. And that is what we can do also with ontologies. It allows us to make precise representation, expression of knowledge of domain concepts. It allows us to share the knowledge to other people. And once we share, suppose you are new to the world. This can be shared and then you learn, right? This is the way to share knowledge and learn. And it allows inference or reasoning, okay? Okay, and then we can use ontologies to allow more of the shared understanding of domain, overcome differences in terms of terminology. Then we can define precise terminology, no ambiguity. Okay, we can even define mappings to say that this term and this term are the same, have the same meaning, or this term and this term is more specialized, generalized or specialized through subclass, superclass. We can have, like, as you said, same as, right? Our same as in the movie example, you can define that this thing here and this thing there is the same thing, but maybe called differently, but they are the same thing. Through subclass, superclass, you can define something is more general, more specialized, more specific. Okay. So that is ontology in a nutshell. Then we can talk about the language, because that is the concept, right? To understand that ontology must comprise these 4 components. Then how can we define an ontology? We need some syntax, some language, so that we can exchange and explain. Okay, so RDF is one. RDF schema is the vocabulary language for RDF, right? Then we have OWL. I think this morning we listened to many presentations that talk about OWL. It stands for Web Ontology Language. Don't ask why it is OWL for Web Ontology Language, but it is. Maybe they don't want to call it WOW. No, it doesn't read easily, right? For European people, for people, we want to make it short as possible. WOW is difficult to pronounce, so OWL is easier. Okay, so Web Ontology Language, but short for OWL. Okay, anyway, RDF we know about already. Notations of RDF in terms of the graph notation, RDF XML notation, the triple notation. Okay. Okay, this one is just Mona Lisa. It's painted by Da Vinci. And RDF schema we already discussed. Okay. This is the schema side. Remember from your assignments 1 and 2, we have the RDF description side, the schema or vocabulary side. Okay, don't forget that. You learn about defining class, defining property, subproperty, class, subclass, domain, and range, and so on. This is what we already learned. Okay. Okay, now web ontology language, OWL. If we look at the, no, I don't have it in this version, but I should bring it. Okay, one moment. Let's try this. I forgot my own slide, not here. How come? Okay. Okay, just look at this, right? Remember, we have so far learned up to, okay, here already, oops. Here already. Now we are here. So this is OWL. And it stands for Web Ontology Language built on top of RDF. That means it has RDF as a foundation. So it builds on the knowledge and structure and the formalism defined by RDF, meaning that the concept of subject, predicate, object is still there in ontology, in OWL. OWL is just one possible way to represent an ontology. There are many other ways to represent ontology in many other languages, okay? But OWL is one way. And it can be represented as a graph, as XML, as triple, turtle, and many more like JSON, IDF JSON. I think Pojanan presented this. It has 3 sub languages, right? Like DL full. Each of them have differences in terms of expressive power. What does it mean? A language that has more expressive power, is it better? What does it mean by expressive power? When you speak some language, and suppose that language has very limited expressive power, such as, suppose I define my new language, Chutipan language. I have only 200 words in my vocabulary of Chutipan's language. Do you think my language will be expressive? For sure, there'll be things I cannot explain, I cannot express in my language, right? That is the meaning of expressive power or expressivity. So this increase light DL full for sure, right? Must look like it is the full language, express everything. DL stand for description logic. Okay, it makes use of one logical framework approach called description logic. Light is of course smaller. So everything is a subset and superset. Full contains everything. DL is one subset inside full. Light is another smaller subset inside description logic. So anyway, the lower these sub languages, the more the expressive power it is. But then, what does it mean? You think it's preferable to use high expressive power language, right? If you want to speak something, you want a language, you want to speak a language with lower expressive power or higher one. And in which context you may want to do what? To use what? Okay, thank you. Good point. So actually, the trade-off, you may want to, of course, express everything. We will, in most cases, we will feel like having more is better, but it means also that it may require more processing power. When the language or when you are using something heavy, because it allows 1,000 features, but that means computing time would be more too. If you are using something lightweight, it may be faster. Okay, that is the trade-off. Okay, anyway, we are not up to full for sure. We will be focusing on light and DL because when you're using the full power and your ontology is huge, it would take a lot of computing resource too. But we are not having the very huge ontology, and we don't need that full power in our in most of the application. I think DL is fine. Okay. This we already discussed, right? We can express everything as ontology in OWL too. In OWL, common prefix, of course, is OWL, as you already saw in the movie database, movie knowledge base that we use for OWL same as, right? I think you saw one, okay, at least for sure. Of course, it has associated namespace to link with, okay? This is kind of standard prefix that we use. You can define a class using our class or IDFS class is kind of equivalent. You can use both, okay? In terms of property, there will be, I'll define two concepts for properties, two sub-concepts, subclasses of property. That is object property or data type property. The differences we will consider, okay? The differences, okay, I already discussed this. The differences is that if, remember, subject, predicate, object, subject, predicate, value. This property P1, the domain is the class for subject. The range will be the class for the object, right? This property P2, the domain is for the class of the subject. The range is some kind of literal value. This is data type property, while P1 is object property. P2 is data type property because the range is a kind of data type like string, date time, Boolean, something like that. Okay, we will look at this in more detail. Okay, we consider this already, expressive power and efficient reasoning support. We will come back to this point. Reasoning, so on and so on. Okay, we will talk about this later. And Okay, let's have a break and we come back to some practice parts with Protege. So everyone be sure you have your Protege ready, install and usable.